Welcome to the Algebra 2 Structure and Method textbook series. This lesson is written on Chapter 6, Section 3, Sums of Radicals. In today's lesson, we're going to learn how to simplify expressions involving the sums of radicals. Before we start the lesson, you should know how to simplify polynomial expressions, and you'll also learn the following new words. Let's get started. Okay, so for our warm-up, go ahead and pause the video and restart when you're ready. I'll show my answers in 3, 2, 1. There we go. How did you do? Now, if you struggled with any of these, go back and review Chapter 4, Section 1. Are you ready to start talking about radicals? When radicals have the same index and radicand, we can combine them in the same way as like terms. For example, the expression 5x plus y minus 4x versus the radical expression 5 square root 2 plus cube root of 2 minus 4 root 2, these are actually going to be combined in the same way. In the first one, we combine our like terms 5x and negative 4x to get x plus y. In the second one, our first and third terms are the same, and we get root 2 plus cube root of 2. Just remember, the cube root of 2 can't be combined with anything else, not the same index and same radicand. We can apply the distributive property to add or subtract like terms with radicals in the same way as other like terms with x's and y's. We're asked to simplify the square root of 8 plus the square root of 98. Remember, you can pause the video and restart when you're ready. First, I write my numbers under the radical as a perfect square times another square in order to use the product property to simplify. Next, I'm going to combine my like radicals. 2 plus 7 gives me 9 radical 2, and my final answer is 9 rad 2. We're asked to simplify the cube root of 81 minus the cube root of 24. First, I write my numbers under the radical as a perfect cube times another factor to use the product property to simplify, similar to the last problem. Next, I'll combine my like radicals to get the cube root of 3. Okay, so for this example, I'm going to first apply the quotient property of radicals. So we can take the radical out and apply it in the numerator and the denominator. So then I can remove the square root of the denominator by multiplying by the square root of the denominator. Sorry, the denominator at all. Now I can apply the product property to simplify. Then I'm going to add like terms to get 5 rad 6 over 3. Okay, so first, in this example, the first thing I'm going to do is distribute my radical 6. Okay, very good. Now that I have rad 12 plus rad 18, I'm going to use the product property to simplify, and I get 2 radical 3 plus 3 radical 2. Now, since there are no more like radicals to combine, I'm finished. I split my fraction, in this case, example 2b, I split my fraction into 2 pieces. Okay, now I'm going to apply the quotient property the other way to get the square root of 21 over 3 plus the square root of 15 over 3. You can see that both of these are going to simplify to square root of 7 plus square root of 5. These are not like terms, so I'm done. For this next one, we're going to throw some variables in. First, I'll write my numbers under the radical as a perfect square times another factor to use the product property to simplify. Next, I'm going to combine the like radicals to get my final answer, which is 6x squared times radical 3x. In this case, we have a mixed expression that needs to be simplified. The first thing that I notice is that the fraction has a radical in the denominator, so I'm going to make sure to move that by multiplying by rad 2 over rad 2. Next, I need to rewrite the first term as a fraction with the least common denominator of 2. I'll combine my numerators, which has like radicals, and that's my final answer. Great job today in this lesson. I hope it wasn't too overwhelming. And remember, the more you practice, the better off you're going to be. To finish everything off, turn to your partner and compare and contrast radical expressions with simplifying polynomial expressions. Remember, that means how to describe how they're the same and how they're different. And I will see you in the next lesson.